Hi guys, welcome to the second video here for week 2 in databases. There's going to be a lot of stuff happening this week. A lot of definitions, a lot of new things for a lot of you students as we kind of get into databases here and what they are and how they work and kind of the ideas behind them, as well as how they should be created and laid out and all that stuff. There's going to be a lot of definitions, that just words that kind of mean things and get thrown around that you might not become familiar with for a little while. Basically, I'm just going to try to draw the global view, and then we'll kind of fill in specifics as we go along here. So don't worry if there's a bunch of stuff that happens this week that you don't fully comprehend right away. That's not an issue. So real quick here, here's just a quick look. We're using Postgres as our backend, meaning that's our database application. So there's a bunch. There's Oracle, there's MySQL. Those are kind of the other MS SQL. The big relational databases, which is what we're going to be working with, relational databases. There's some new ones. There's Hadoop, Redis. These are kind of the key data stores. They're not relational databases. They are just they just basically have two columns as opposed to multiple with different types of data in them. So here's the documentation link. It'll be included in the documents that I give out. So you can come on here, look things up, kind of see what's going on. And I've included some links to this as well. So that is that. And that said, kind of databases themselves, as we get going here. I've set up a database for everyone. So we're not really going to be creating databases in this course. To create a database, you really just tell SQL, hey, create database, and give it a name. The database itself is just kind of a collection of tables and data. An application might have one database, it might have multiple databases, but it's not really something that's totally relevant. What we care about learning here is the tables and the relations and the columns and the rows and the keys and the indexes and the uniqueness and the data types and what null means and default values and constraints and the commands and all those types of things that are really related to tables, not so much databases. So when we talk about learning databases, what we really mean is learning what's inside of them, not really learning them as a thing. So that said, tables, we're going to kick right off here. I've got this Excel, which will kind of just give a visual to understanding tables a bit more. This in itself, what you can see on the screen here, is a table of data, if we can call it that. It has some columns. So when we talk about A, we're talking about the ID column. We talk about B, we're talking about the level ID column. C, we're talking about the first name. D, the last name. E, the business name. F, the business city. G, the business state. And H, the business zip. So these are the columns, sometimes called fields, within the database. And I'm just using Excel to illustrate this. Excel is not a database program. It's just a visual way without me having to draw anything. I don't have a whiteboard. If we were in a classroom, I would whiteboard this, but I don't. So this is kind of the simple way to do that. So when we talk about a column or a field, this is what we're talking about. We're talking about, here we've got this thing called business name, and every row, rows run horizontally. So we talk about a row. We're talking about, this or this or this or whatever. Every row in this column is going to have the same type of same type of data, same data type. That's what I'm trying to say. So all of these things are going to be related in that they're all business names. All of this data in this column here is going to be the first name in relation to this row of data. So when we talk about a column or a field, this is what we're talking about. When we talk about a row or a record, this is what we're talking about. This horizontal data as opposed to the column and field, which is this vertical data. So that said, when we create a table, we don't actually put any of the data in it. All we're worried about is kind of these titles here, the columns. When we create a table, we give the table a name, and then within that we give columns names, and we give columns data types, basically rules that column data will adhere to. So if we're thinking about something like an ID, let's not go with ID, let's go with first name here. If we're looking about this first name column, when we're defining it, we're going to be defining the first name as some type of characters, right? Variable characters of some certain length. Call it 40 characters maximum. When we're doing a business name, we're talking about variable characters as well. Maybe it's a little longer. Maybe it's 100 characters long as opposed to 40. When we're talking about business state, if we're storing data in this manner, it's variable characters, but it's only 2 in length. That way we don't waste space on our system. How about this one? We're talking about business zip code. We're talking about a number now at this point. So no longer variable characters, but rather instead maybe a small integer or something like that. So I've included some links that kind of break down the different types of numbers systems, number data types that Postgres has within it, and each type of database application, whether it's MS SQL or MySQL or Oracle or Postgres, are going to have different data types. So it's specific to the database, but pretty much all of them have things that can be replicated in other ones. They're all going to have some type of Boolean data, whether it's a tiny int meaning 0, 1, or whether it's actually true, false, or whether it's like Postgres and stores T or F. They're all going to have some type of Boolean. They're all going to have some type of variable character, meaning that it can be letters or numbers combined. And then they're going to have something like a text field, which is basically just like a bunch of text. It doesn't have a limit. If you ever used MS SQL or MySQL rather, they have like a blob data type. Here it's just called text. With numbers, there's a bunch of different types of them, and it's all based on how precise you want it to be and how much space you're allowing the length of this thing to take up. So here we're talking about a length of 5 when we're talking about business zip, right? There's 5 characters, 593. That's 1, 2, 3, 4, 5 characters. This one somehow only has 4. It's I don't know if that's valid or not. I didn't create this data, but the maximum here would be 5. So we wouldn't need to use some like a double or a real number or something that has really, really precise and allows to store 100 characters. We don't need that. It's just going to take up too much space in the database because databases are essentially stored in files, and files will eat up your hard drive if they get too large. Okay, so then we've got another data type that's not listed here is the timestamp, and it's just a normal timestamp. There's also date. There's also timestamp with time zone. There's a lot of things that are like that. There's a Unix time if you want to use epoch seconds since 1970. Lots of different things with that. And now one more that I want to touch on here before we kind of go anywhere is this ID field. So if you think about an ID, sometimes you want the database to kind of track individually an auto increment every time you insert some data, right? So maybe I want to add 5 users to the database, but I don't want to remember how many users are currently in there. I just want the database to figure it out and add another number to the record. So this type of data, if it were auto incrementing, meaning that the database essentially tracked how many things were in here and then added another one to it when it added more data, that is called a serial data type within Postgres. And I'll use it in my example so that you guys can see. It's SERIAL, and it basically is just an auto number. If you've ever used MySQL, integer auto number. I'm not sure what it is in MS SQL, and Oracle does some funny things if you've ever used that. So that's just a little bit about kind of tables here, columns, as well as rows, that type of thing. The other things that I can touch on here would be a primary key. I'll touch on that. I won't touch on foreign key at the moment. We'll see that a little later on. But a primary key is basically something that is unique to each row. So when we're talking about this serial number, that thing is going to be unique in each of these rows, whereas this other data might not be. Level ID, okay, well, this one's a 1 and this one's a 1. So that's not unique. This guy's name is Christopher. There could definitely be someone else in here named Christopher, right? So that's not unique. Last names, they might look unique, but here you've got boys and boys. So that's not a unique field. Business name, people could work for the same business. They could be in the same city. They could be in the same state with the same zip code. So the only thing that's unique here is this ID field, which is often the case that you have to create a field to be unique, to have a primary key on a table. And the whole goal of a primary key, of adding some ID, some identifier, is that later on when you want to reference this row, right? If I want to talk about this row, I can talk about whatever table this is. Let's say this table is called customers. I could say the customer's ID, and I could say customer ID number 5, and you'd always know that I'm talking about this person, right? So if I wanted to store that data in another table somewhere, all I would need to do is pass this 5 and just know that it's coming from the customer's table. And I could easily go in here and look up who that is without having to duplicate this data anywhere else. So that's another thing. The normal forms link that is listed in the documents that I've added. That's kind of the big thing in normal forms. There's a lot of stuff in there, right? There's 6 normal forms, but really there's 2 big things that you need to know when you create tables for relations. One is that each column should only store one type of thing in it, right? So this only stores a first name, Christopher, Ben, Mukesh. This only stores a last name. I didn't even store, you could have done this as one column and just called it name, and it would have been, Ben Albert. But even pushing it to that level, you're limiting what you can do with the data in terms of later on when you want to search for certain things. Whereas here, if you can break it down to the simplest of things, then that allows you to do more with it later. So you'd never want to have something like business address where it had, Verona, Wisconsin, 53593, and it's all stored in one, because it makes it very difficult to search on later. So that's one of the normal forms that there's only one type of data in each of these columns. And the other big thing is don't duplicate data. So like I said, if we were creating another table somewhere and we wanted to reference a customer, if we wanted to reference customer, 1, I would never want to store their name or their business name or any of the information that exists here in some other table. Because what it would mean is that if I were to ever update it, I would have to update it in more than one place. And that would likely not happen because we would forget, and then we would have misleading data within the database. It could be right in one spot and wrong in another. Okay, so just having a look here, this is a table. So we're going to kind of get in here into the system a little bit and try to learn a couple Unix commands, a couple Postgres commands, and then see how to make a table, how to insert some data into that table, and then how to just quickly look to see if that worked. And then there's going to be an assignment that's pretty much to do exactly that, just kind of on your own. And the tables will already be defined for you. You just need to create them and figure out what data types to use. Okay, so based on the video earlier, I assume everyone can SSH into the server. If you're on Windows, you're going to be using PuTTY. If you're not on Windows, if you're on Unix or Linux or Mac, the command is SSH, whatever your alias is that I'm going to email out to this server. So when I pop that in here, it asks me my password, and I type it in. All right, cool. So I connected to this thing. So that's all fine and well. So quickly here, it's just some Ubuntu commands. So you're not on Ubuntu, right? You're on Windows or Mac or whatever. Well, the server that you've just connected to is running Ubuntu, as it says here, 13.10. So you're actually connected to a Linux system, meaning that to interact with it, just say to do these things, these commands, you're going to need to know a little bit about it. So the first thing I'll use here is this pwd command, and it basically means, hey, you know, where am I? Where am I currently at on this system? What am I connected to? And it shows me that I'm at home/JLake. Okay, so if you're used to Windows, you know, it's got things like this. You know, something like that. This is the equivalent of that on Ubuntu, on just Linux in general, really. This home directory is kind of the same as that. So on Windows, if I were to type dir, it would give me a directory listing. Here it does nothing. For that, I'm going to need to use this ls command. Still, there's nothing in this folder. So if I go up a folder, you'll now see it tells me I'm at, you know, /home. So if I do pwd, it tells me that I'm at home. So if I run a list on that, it'll show me that there's, you know, some folders here that belong to other people, and then this CITPT 413 folder, which we all have access to. If you try to go to somebody else's folder, so if I try to go to Amy's folder here, should tell me I don't have access to it. You only have access to your own stuff, just to, you know, eliminate some issues there. Okay, so if I go back to my folder, I'm going to come back out here, back to this home. So if you're ever just kind of like milling around on the server, I don't know how much access you have or what you're trying to do on it. You don't really need to do anything. But if you ever find yourself lost, you know, your PWD, and it shows you somewhere you don't want to be, you can just type CD and hit enter, and it'll always take you back to your home directory. So, you know, if you want to store files in here, things like that, we will be doing some of that. And then exit, as it says here, will close the connection. Okay, so the command that we're interested in now is this PSQL command. So if I type PSQL, it's going to open this Postgres prompt, basically, meaning that I've opened Postgres, and now what I'm typing is being sent to the database server. So these commands worked within Ubuntu, and now we're going to look at what kind of works within Postgres. And Postgres has got some kind of, it's got this, you know, funky backslash thing going on in order to do everything. So if I just give a \?, it'll list here for me a bunch of information, and it kind of stops here at the bottom, and it says informational with a colon. If I hit enter, it'll start to bring out, you know, more data. So I can, you know, scroll through here, and if I, you know, hit up on my keyboard, it takes me back up, and down I can scroll. I can just scroll through this information here. So there's a bunch of commands here. When you're done, you can hit Q, and it'll take you out of that little pop-up. So if you ever get, you know, stuck in there, and you don't know how to get out, and you're hitting keys, Q is the key to get you out of there. So that said, so if I say /L, it's going to tell me here's all the databases that exist right now on this Postgres instance. So you can kind of see, you know, here's everybody in the class, and they have one. There's also the CITPT 413, which is a global database that everyone has access to. But otherwise, you know, there's some standard ones, this Postgres database, and then this template 0 and 1 database. But otherwise, they're just related to all of us. So that's, you know, everybody's database. So if you say Q again, it'll pop you out of there. So if I then say /DT, that'll show me all the tables within my current database. And I currently don't have any databases or any tables within my database. So nothing shows up. If I say /Z, it'll give me a little more information. Again, still nothing. And then if I want to quit, if you're stuck in here and you don't know how to get out, and, you know, Control-C doesn't work, then you can say \Q, and that'll pop you back out. So I'm going to come back in here, though, and I'm going to create a really simple table. So just to go over it here, you can see my text just says create table test, and then it's got a parentheses. We could just create table test without anything in it. Or we could not. Okay, so we could, with empty parentheses, we can create this table called test, and it'll create it. So if I say, okay, well, what tables are in my in my database? Well, it says now there's a table with the name of test. It's in the schema public. For now, we don't need to worry about that. Everything is going to be public. What type is it? It's a table. Who's the owner? I'm the owner. Okay, so I'm going to drop that table real quick. That just means delete it. Okay, so if I run this again, it's going to tell you nothing's there. So if we look in here, what do I want to create? What columns do I want to create? Are these kind of next things that are listed here? So we've got the table called test. The first column, I want an ID in the same way that this thing has an ID. And I want that ID to be a serial, meaning an auto-incrementing number. And I'm also going to pass in this identifier here that says not null, meaning that it's going to be auto-incrementing and it's never going to have the value of null. So null just means that there's no data. So that it's never going to be null. It's always going to have some number in it. Okay, so then I want another column called name. It's going to be, again, a varying character of length 32. Also can never be null, meaning that if I do something, I try to insert some data into this table and it doesn't exist, I mess up, I goof up, and I don't put in a name, then the database is not going to accept it. It's not going to add it into this table. So we can see an example of that here in a minute once this table actually gets created. And then on this, I'm going to create a constraint named test p key, and it's going to be a primary key on the column ID. So if you look at kind of the notes that I added in relation to primary key, it's the one thing that's unique in everything that we can use to identify it if another table wanted to reference this data. Okay, so I'm going to take this data here, I want to copy it, and I'm going to throw it in here. Okay, so you'll see it copied in, right? I'm using tabs. If you use spaces, it might not work as well, but I'm using tabs here in my editor in Sublime, so it works fine. It doesn't look that great when it's copied, but it does work fine. So one thing that you need to note is that every statement needs to end in a semicolon before it will be ran. So you can copy this without the semicolon, and I can hit enter, and it's still just waiting for something to happen. It's going to wait until you put in a semicolon and hit enter. Okay, and then it's going to tell me, okay, it already exists. So if I say DT, well, I've got that table back. So that's all cool and well. So now we can use this other command that we've got listed here, this /d table name. We called it test. And it'll tell you a little about the table that we have, this test table. So it says we have two columns. One's an ID. The type is an integer. Remember what I said, that if we use this serial type, it'll actually create an auto-incrementing number. Okay, so that's storing it as an integer. And it has some modifiers on it. So one thing is that it's not null. That was based on us not saying not null. And then it says its default is the next value in this sequence, some stuff that looks like code. That's the sequence itself telling it to auto-increment. So we'll just let the system take care of that. We don't need to code anything for it. It has another column called name, which has this varying character of length 32, and it's not null. It has an index of test p key, which is a primary key, and it's a B tree. That's just kind of more information on how it's being stored. So that's an index. We'll see more on those later, and you can see the definition of it. Okay, so from here we want to say, hey, what's in this database? What's in this table that we just created? So we created one, right? We use this command to create table. And now to get data out of it, I can say select star from test. And I can run that. And it tells me there's nothing in it. Okay? So this is kind of how you read from the database, is a select statement. So if I throw that in here, So this test is the same as this test, right? It's the name of the table that I created. Asterisk just means give me everything. Give me all the data that this table has. So it's basically saying read all the data that's in test and output it to the screen. So in the same way that when we look at this table, which I just kind of fakely named customers, if I were to say give me all the data in customers, it would look like this, right? And it would scroll and it would have a bunch of stuff in it. We're doing the same thing using this command. Give me all the data that's in test. And it says, okay, there's 2 columns, one's ID, one's name, but there's no rows of data. You just have the columns, you don't have any data. Okay, so how do we enter data? We can use this little command here, this insert into, and then where we want it to go. We want it to go into the test table, and then we want to tell it what values. In order to allow the serial to count on its own, we just pass this value which says default, and then I'm going to pass my name in here. And for Postgres to work, you need to use single quotes. Double quotes kind of throw things off. So single quotes are what are needed in order to pass in strings, characters of varying data type. So if I go ahead and throw this in here, okay, cool. So it tells me it inserted it, and I can test that. So Postgres and Ubuntu, if you hit up on your keyboard, it'll cycle through commands that you've just entered. So I didn't want to type select star from test again. I just wanted to run it. So I just hit up twice. Okay, I ran that. All right, so previously it said, I had these 2 columns, ID and name. I had 0 rows. Now it says, I have ID and name. I have a value of 1 and a name of Jake, and I have 1 row of data. So if I were to, enter, some more data, if I inserted in, Lake as another person here, okay, it inserted, and then if I were to select all the data, you can see here that it auto-incremented this, and that it added, more data here. Because I don't have, any unique constraints on my name column, I could actually, enter quite a few users here with the name of Jake. If I were to, pull it out. So we've got, user 1 is Jake, user 2 is Lake, and then users 3, 4, 5, 6, and 7 are all Jake. So that's just kind of a simple, look here at a couple things. So we created a table with a serial data type as well as a variable character data type. We then inserted data into that table, and then we were able to test in terms of selecting some data out, just saying, hey, read this table and tell me what's in there, in order to verify that it worked. So this is kind of the beginning of looking at databases. We now can create the tables as well as put data in them, which are really quite standard things. But you need to know how to do them so that it makes sense. Where's the data coming from that you're selecting, that you're running all these reports on, because a lot of times in these SQL classes they teach you just how to use the select command. Reason being that it's going to get a lot more complicated than this once we start getting a lot of data built up and ran across a bunch of different tables that have cool relations between them, and you want to know the answers to certain questions. It all comes down to this select. But it's also very important to know how to create good relational database tables, good relations between the tables, solely because, as I said, I think previously, there's a lot of people out there who understand SQL just enough to be very, very dangerous with it, to create very poor relational databases that maybe, the select statements are 200 lines long when they only, if the database were designed properly, would be 5 lines long. So that's kind of one of the reasons that we're taking the route here of learning, the creation as well as the insertion of data prior to really getting in depth on selects. But we will see that soon enough. So the assignment then this week is going to be to, as I said, create a couple tables with proper data types on the columns, and then just throw some data in those tables. And that's really it. That's kind of how we're going to get started here. Okay, so that's all I got for you. Let me know if there's any questions. Thanks.